All right, so let's look at a breakdown of the sympathetic nervous system
You gonna make that bigger?
and the sympathetic nervous system. Sympathetic nervous system and parasympathetic nervous system. So you have really what's represented on this is the sympathetics on this side. You have parasympathetic on this side. And you can see that both systems actually innervate the same organs. That you can see down here in the stomach and the intestines that the sympathetic nervous system innervates those, as well as the parasympathetic nervous system innervates those as well. Up here in the lungs, you can see that the parasympathetic nervous system actually constricts bronchioles, and the sympathetic nervous system actually dilates the bronchioles. For your vessels, the sympathetic nervous system causes a lot of vessel constriction. My understanding in the peripheral vessels is that the parasympathetic nervous system doesn't play as large a role in the vessel side. There probably is some vasodilation that occurs as a result of the parasympathetic nervous system. You can see up here, you have a cranial nerve here that runs out here to the eye. That's not the vagus nerve, but that which cranial nerve is that? It's not the optic. It's the third cranial nerve. The third cranial nerve, also known oculomotor. That's right. It's the name of it. It's the oculomotor nerve. And it's what you're looking at when you check to see if somebody's pupils are equal and reactive, the same compared to the other. If there is pressure from intracranial pressure that actually pushes on that third cranial nerve, it will actually cause dilation. When the sympathetic nervous system is activated, your pupils dilate so you can see better. Parasympathetic nervous system is activated, the pupils will actually constrict. You'll see that if we were to give atropine, we would be blocking which one of those nervous systems?
Parasympathetic.
You're blocking the parasympathetic nervous system. So if you look at somebody's pupils after they receive atropine, what would you expect to see in their pupils?
Dilated.
Their pupils would be dilated. That's right, because you're blocking that system, and that system, when stimulated, actually constricts the pupils.
Now you know people are overdosing by their respiratory drive and all that good stuff, but also the pupils are pinpoint.
For like a narcotic overdose causes a central nervous system depression, significant central nervous system depression. And in depressing the central nervous system, it would cause the pupils to actually constrict.
When there's a headache or one big and one little, that means it's something.
That means there's pressure on you have two oculomotor nerves up there that are cranial nerves running to the eyes. One of them's being compressed, and it is preventing it from controlling the dilation and constriction of the pupil.
Swollen up in there.
Hey, what does fixed mean for your people?
Fixed means does not react to light. You shine light in there, it should constrict, but it doesn't. Okay, so fixed, that's what that means. All right, so y'all remember I told you about preganglionic and postganglionic. That's not really represented here, but do y'all remember I said the preganglionic synapses for the sympathetic nervous system is near the spinal cord, real close to the spinal cord, that first synapsis is. And then the second synapsis occurs right out there where it innervates the actual cells of the target tissue. And for the parasympathetic nervous system, the preganglionic synapsis is actually that neuron chain that runs out there to the first synapsis, the preganglionic synapsis. That's pretty long. So the preganglionic synapsis for the parasympathetic nervous system usually is pretty close to the organ, and then you'll have a shorter neuron that will then go from that synapsis to the actual organ itself. Okay? Any questions on that? So, in review, y'all help me go through this. The sympathetic nervous system is activated because I'm bleeding out. My blood pressure begins to drop, and my baroreceptors actually send less signals to the brain, which tells the brain the blood pressure is dropping. Which system will be activated?
Sympathetic.
Sympathetic nervous system. At the preganglionic synapses, the first synapsis in the chain, acetylcholine is released. It will attach to what receptors? Nicotinic. Specifically, they're nicotinic N, which to me, I attach the word neuron to that. Okay, nicotinic N. All right.
For the pre.
Then
For the pre-ganglionic.
for the preganglionic, those are nicotinic N's. All right, N is in Nora. Then the impulse will travel from that synapsis on down the neuron chain there until it reaches the end organ. In the case of the heart, what or in most of nearly all of the postganglionic synapses, what chemical gets released? For the parasympathetic nervous system. Did I say sympathetic nervous system? Okay. Sympathetic nervous system, it would be norepinephrine. That's correct. So norepinephrine would be released. There would be a positive inotropic, dramatropic, and tronotropic effect on the heart. The heart would then do what? Speed up, increase its strength of contractions, and increase cardiac output. Okay? In your vessels, it would cause the peripheral blood vessels to do what? Constrict. That's exactly right, to raise the blood pressure. In the area of the gut, what would it actually do? For the gut, not the vessels, but what about the activity of the gut? Sympathetic nervous system kicks in, the activity in the gut would slow down, okay, if your sympathetic nervous system kicked in. All right. Then you have the parasympathetic nervous system. Again, the preganglionic synapsis is going to be much closer to the organ. What chemical will be released at the preganglionic synapsis of the parasympathetic nervous system? It will be acetylcholine, and it will attach to what receptors at the other side of that synapsis? In the dendrite of the nerve coming after the synapse. It will be nicotinic N receptors. The impulse will then travel on to its target tissue, and there will be, for the parasympathetic nervous system, the postganglionic neurotransmitter that would be released, and that would be acetylcholine too. Now, those would be muscarinic receptors that acetylcholine attaches to at the postganglionic synapses. The receptors there are muscarinic, and depending on which organ they innervate, it will either have a stimulatory effect or an inhibitory effect. Now, back at the preganglionic synapses, when we talk about those being nicotinic N's, the reason I think it's important for you to remember that is because out here in your skeletal muscles, there are nicotinic receptors that actually respond to acetylcholine so that we can move our skeletal muscles. When a motor neuron carries an impulse out here to the synapses at the neuromuscular junction in your skeletal muscles, it also releases acetylcholine. So you've got to have a cholinergic receptor there in the neuromuscular junction for it to attach to. And those are nicotinic M's. And again, for me, that's muscular, nicotinic muscular. Okay? So there's enough difference in those two receptors that they can make drugs like atropine that you can give to somebody. And atropine will affect muscarinic cholinergic receptors and have an effect on the heart. Atropine would speed the heart rate up by blocking the parasympathetic nervous system. And they can make a different drug that's also attaches to cholinergic receptors, but they can be specific enough that they attach to nicotinic M's in your skeletal muscles. So atropine can be given to somebody without paralyzing them. And you can also give a paralytic that would affect the nicotinic M receptors and would not have a huge effect on the heart. Okay? So while you have cholinergic receptors, acetylcholine attaching to cholinergic receptors, muscarinic And nicotinic, the nicotinics are further divided into nicotinic ends and nicotinic ends. Nicotinic ends and nicotinic ends.
You think on the down structure as well, dendrites, axons, cell bodies?
Yes, sir. If you are looking at the first synapses, preganglionic synapses,
Dendrite.
the impulse is traveling to the synapses on the dendrite of that neuron. You'll remember it always carries the impulse away from the nerve cell body. And then the nerve cell that's going to be receiving that impulse is the dendrite on the following neuron chain. Does that make sense? And the dendrite then begins that initiation, carries the impulse to that nerve cell body and down the dendrite to the end organ tissue.
Yeah, if you touch something
I'm sorry,
off,
the axon.
if you touch
I said
something
that
off,
wrong.
axons are gonna send it back.
Dendrites, look at dendrite and axon on one nerve cell. And the dendrites carry that impulse from the previous synapses to the nerve cell body. And then the impulse goes through the nerve cell body and leaves the nerve cell body, traveling on to the next synapses on the dendrite. So the dendrite carries the impulse away from the nerve cell body. The axon carries the impulse away from the nerve cell body. The dendrite brings that impulse to the nerve cell body. Okay.
Afferent.
That's what I'm thinking about.
Now, when you talk about afferent and efferent, you're talking about the direction of travel of a nerve impulse in general. Either a nerve impulse is traveling toward the central nervous system or away from the central nervous system. Do y'all remember afferent and efferent?
Somatic.
Efferent goes away from the central nervous system, so it's traveling out to an effector organ. Okay, efferent, effector organ's the way I remember that. Afferent is carrying the impulse toward the central nervous system. So sensory neurons are always afferent because they're carrying, if I touch this book and I can feel it, that impulse is traveling to my brain. Okay, so that I have that I can sense the feel of that book there, and that impulse is traveling toward. So that is afferent. Me reaching over to touch the book is musculoskeletal activity. That impulse is traveling from my brain and my spinal cord to my skeletal muscle to move my arm. That is efferent. That's correct. Any questions on that?
Trevor, did you get your elbow?